Welcome back. Today we are going to go over the lerp function and how people are most likely using it incorrectly. So let's jump right into it. So lerp is a mathematical function that takes 2 points and then finds a percentage of them. So I have this illustrated right here in my start function. So our lerp value is equal to mathf.lerp. We give it the first float and the second float, and then we say the amount or percentage that we want between them. So for example, with some hard numbers, if we said float A was equal to 1 and float B was equal to 2, and the amount was 0.5, this would return 1.5. Where it is represented a lot of the time is like this, right here, where lerp is point A, point B, and then a rate, a time. That's not how it normally works. It sort of functions like that inside of the update function, because what happens, let's take time.delta time. This is a value that's going to stay the same, like 0.01, but our position is changing because we're setting our position equal to the result of this lerp function. So as we inch forward, it's then going to take the average between us and our destination by a little bit more, and then by a little bit more. But each time that number is shrinking. So if I come over here and I maximize on screen, if I press the 1 key, you can see lerp working this way. What you're going to notice is we start moving quickly, then we slow down as we reach the finish. This works, but this isn't ideal for animation all the time. Sometimes you do want to slow down effect. However, there is a better function for that, smooth damp. The correct way of using lerp is set up like this. So you set up a timer where you set a time variable and the duration of your lerp, however long you want your animation to take. You lerp from your first position to your second position at time divided by lerp duration. So time is whatever the current time is on our counter, and then lerp duration is the total animation. When you do it by this fractionally, it'll be smooth. And then you increment time by time.delta time. This just ticks it up. Otherwise, because again, this won't get you perfectly to your destination, you just need to reset things. So you're going to set time back to 0, and then you're going to set your position to 100% be at point B. So if I press 2, you can see that working here. So you can see I'm smoothly moving at the same rate to the other part, and then it sets our time back to 0 and it resets, and we do the whole animation over again. If I release the button along the way, we'll stop moving at our location. Lerp can be used for more complex animations as well. This uses coroutines. So right here I have a very simple timer that every attack speed seconds, this coroutine is going to trigger. And we use this function down here. So we create a float that is a percent. This is to represent how much of the animation you want to happen. So while percent is less than or equal to 1, so 1 being the animation has completed, we're going to increment our percent by time.delta time plus 1. This is going to be how this float is how fast you want your animation to play. So if you want it to play faster, you would just change this to like 2, so it'd be 2x. 1 just by default normal speed. Then we have a math formula. So we can put formulas in here. This is a formula, which I'll show on the screen, graphed, that returns a curve. So at 0, 0, it is at the origin on a graph, and then by 1, it is back on 0 in the y height, and 1 at the x height. But in the middle, it arcs up to 1 at the top, or for whatever values yours comes out to be. But the important thing is you have that curve. So the beginning is at 0 and the end is at 0 in the x-axis. What this causes to happen when you toss in this formula to lerp is we are going to go to our target position and then return to our position. So this is useful for kind of like a lunge attack or something like that. So you can see I'm just holding down the button. We're going to move up and then we're going to move down. And the formula is returning values of 0 when it is down at the bottom and 1 when it is up at the top. So 0% of the difference between them puts us at the first point. 100% puts us at the second point. Then it increments from 0.1, 0.2, 0.3, 0.4, 0.5, so on and so forth. Once it reaches 0.5, it will be all the way up here. And then once it resets, it's going to fall back down. So that is the importance of the lerp function. You can do tons of things with it. It is important to get away from doing it by the speed because this will have weird interactions. You want to do it this correct way where you divide it by time divided by lerp duration. There's an article I'm going to include that is pretty well done. It covers a bunch of different scenarios of using lerp. You can use it for pretty much anything: scaling an object, rotating an object, changing the color of a material, and so on and so forth. I hope you found this video interesting. Please hit the like and subscribe buttons, and I will see you in the next one.